It's no secret that data structures and algorithms are the cornerstone of any whiteboard interview. But they're very hard to solve, especially if you have very little time. Well, in this video, I will show you how to make data structures problems simple and how to solve them fast. So keep watching.
So here's this week's problem. Basically, if you're given a binary tree, how would you print it in level order? I already have an example for your reference on the whiteboard.
Okay, so I think I understand the problem. This looks like a standard breadth first search traversal. So let me just go through it. I think the catch over here is just the new line segments. So I'll need to think about that.
Yep.
So let me go through this. The way I would implement the breadth first search is with a queue. So if you don't mind, I will just lay out the example, and then we'll take both of us to the logic behind the example.
Sure.
So let's say I have a queue of sorts, and right now it's an empty queue. And the way I would do it is I'll start at the root node. Let's say this is the root. And the first thing I'll do is I'll push the root node in the queue. So in this case, I'll push 2 in the queue. And then for that level, I'm done, right? So then I'll see, okay, is there anything in my queue at the moment? At this point there is, right? There's 2 because I just pushed that in. So I'll dequeue it, and I'll have 2 on my hands.
Okay.
So actually, when I put 2 in there, I'll also put in the level at which I found it. So when I'm starting at root, let's say I call it the level 1. So I won't just put in the value 2 then. I will put in the node itself. I'll put in whatever this is in there, and inside of the node then I'll also instantiate a property, like an instance property that I can access to get the level.
Okay.
So if you look at this node, then you can think of that node as having its value to be 2, and then I'll put in the level. So the first S2 is the first one that I'm encountering. I'll just start with level 1.
Okay.
And then, of course, it'll have as it's a binary tree, it'll have the left child and the right child. So let's say I have the left and I have the right. And they're both some node, some node. So just giving it a level will help me with the new lines.
Okay.
So let's say I put in this node 2 in there, and then I dequeue it, and I look at, and also before I even start, I will instantiate what level I am at the moment. So outside of this queue, I'll say current level equals 1. So I dequeue it, and I see, okay, the value is 2. I output the value 2, and I say, okay, current level is 1. The level of this node is 1 as well, so I don't need the new line right now. Then what I'll do is I'll look at its left child, and I'll on queue the left child on here. So in this case, it's 3, the node 3. But whenever I'm adding the children, I will increment a level and add it to its node. So this is still a node that I'm adding. So in case of the node 3, it will just be value 3 and then level 2. So this one is dequeued, and I'm adding the node 3, and then I'll also add the right child. So that's 4.
Okay.
Same thing. So its level will be 2 as well. And then I'm done adding all of the children. So I'll say, okay, is there anything in my queue? There's node 3, so I'll dequeue it, and I will say, I will look at the level. Now I'll say, oh, it's level 2, but right now my current level is level 1. So I just encountered a line break, a new line.
Okay.
So I will add that new line. So let's say it's \n, and then I will print its value.
Okay.
So then I have 3.
Mm-hmm.
I will dequeue, and I have 3. I put on the value 3, and then I'll also look at the children. So in this case, 3 just has 1 child.
Mm-hmm.
Same thing for 3. I will put in. So this will be the node. I will increment the level for this node.
Yeah.
So it was level 2 for this. So this will be level 3.
So how you increment the level for the child? Like you check the parents level and then increment it, or you check the current level and increment
the current level. So not this current level. I look at, so if I'm looking at the node 3, I see, okay, what is the level of node 3?
Okay.
So it's
basically
child.
you are looking at the parents level and then
Yep.
incrementing the value of level and assigning it.
Yep.
Okay.
Yeah. So in this case, it's level 3. So let me just put 1 on it.
Okay.
Now the next thing I'll do is I'll dequeue again, and I see, okay, it's 4. In this case, it's the same level as level 3, and that is the current level. So I just put down 4 as the value.
Yeah,
and
so that we don't get confused. The current level is 2, right?
Oh, yes, the current level is 2. Yes, I forgot to update that. So we're at 4 right now. We'll do the same thing. I'll on queue its left and right by after incrementing the level. So the level for 4 was 2 as well. So levels for 2 and 5 will be level 3.
Yeah.
So 2 and 5. Perfect. So now I dequeue again, and I look at node 1's level. I say, oh, it's something different than the current level. So I do a line break, and I print its value, and I see whether it has kids. It doesn't have kids in this case, though. So I just move on in the process, and same thing with 2, and the last one wasn't 3; it was actually 5. So same thing with 5. So this is the same as the output you had over there.
Okay, so whenever you print a line break, you are incrementing the current level variable, right?
Yes, exactly. So in this case, this will be 3. I forget to increment it over there. Yes.
Okay, looks good.
So if you don't mind, I think we're clear on the implementation. Yep. I will just go on with the function now.
Yeah, sure.
So let's say in the function, the input is the root node. So let me, as we are doing a breadth first traversal, let me name the function BFT, and let's say it takes root as an argument. And what we do is, even before we start with anything, we set the level, the first level that we start out with. In this case, it'll be level 1. So let's say level equals 1. So there's a pseudocode. And then we also want to instantiate the queue.
Yeah.
So I'll say queue, let me just call it queue, equals new. So there are actually multiple ways to implement a queue. The most optimal way is obviously with a linked list. Now, if you don't mind, the less optimal way is to do it with an array. But usually with languages, we have a lot of helpful functions to help us slice and dice the array. And if I were to do it over here with a linked list, it would take me a lot more time. So is it okay if I just move forward with an array?
Yeah, that's fine.
Perfect. So I have a new queue. Let's say it's just an array. So instead of me calling it new queue, let me just instantiate an array. Okay, so the first thing I do is I push the root into the queue, and then our traversal will start. So I'll say queue dot push even before I push actually the root to the queue, I want to modify its instance property. So I want to add the level property to it. So I will say root dot level equals 1, let's say, or equals whatever the level is at the moment. And then I will say q dot push root.
So just to make it clear, so your level variable over here is the current level that we used?
The level variable, yes, so this is the current level.
Okay, so can we just name it as current level?
Yes.
So we don't get confused with that?
I think that's a very good point. So level, let me also just say this is current level. Perfect. So I push the root, and then we'll start with a while loop. I'll say while q dot length. Basically, while there's something in the queue.
Yeah.
Let's keep doing this. So I will. So I'm familiar with JavaScript. The way you take out the first element from an array in JavaScript is just to do array.shift. So I will, but just to simplify it and just look at pure pseudocode, let me just use a dequeue method, and then we can understand that it's shift. So I'll say node equals, so node scope is within this block. So I'll say node equals q dot dequeue.
Okay.
Then the first thing I want to do is print the value of the node. So I'll say print q dot value, no, node dot value. Then what I want to do is actually before I print nodes dot value, I want to check whether the current level is the same as its level, because if it's not, then I will need to prepend the new line variable. So let me erase this and say if node dot level is greater than current level. So if this is the case, then we want to increase the cur level and then print the new line. So cur level plus plus and print \n. And then I will print the value. Print node dot value. So in this case now I have the value 2.
Yep.
So the next thing I want to do is I want to on queue its children. So I will say if node dot left if node dot left, then node dot left dot level equals node dot level plus plus. No, plus 1. Let me, I don't want to increment my current node's level. I think plus plus will increment that. Plus 1, right? And then after I increment it, I want to on queue it. So I'll say q dot push node dot left. And same thing with if node dot right. Basically I will have the same logic here as well. Instead I will just be pushing node dot right.
That's fine.
So in this case now, if I just go through this algorithm, when I have 2, I will know that the level is 1. Then I will be on queuing its kids, and then I'll move on to this node, and that point I will hit the if block over here and I will have the new line.
Correct.
And the same thing with when I'm at 1, all of a sudden the curl level has increased because I increase it right there. So the moment I encounter that the node.level, the current nodes.level is greater than curl level, I increase it right there. So the level will be incremented over there as well. So I think this function should yield us that result.
Yep, it should. So we have our function over here.
Great. Make sure you subscribe and comment down below what types of problems you want me to cover next. And I'll see you next Wednesday.